Hello everyone, it's Rafael Gutierrez. Welcome to my channel. Today I wanted to talk about pretty much fascia, what it is, and try to demystify it from martial arts. Now this actually came from a question from Mr. Noah, I hope I don't mess up his last name, Galan. He actually trains with the Emory University Shotokan Club, and he actually sent me an article asking me what I think about fascia being used in martial arts. And before I actually go into that, I want to talk about how people collect data in an academic sense. And what I'm going to do is first tell you about when I translated a book and why it was interesting. So I actually did get this one translated into Spanish. It's that one over there. And when I did, I had a professional translator do it. Now, someone asked me why I would do that when I'm fluent in Spanish. I can read Spanish. I can speak Spanish. I can write Spanish on computers. If I'm handwriting it, I tend to make a lot more mistakes. But I technically am fluent in Spanish. Yet when it came time to translate, I went to a professional translator. Nice thing about a professional translator is some professional translators will have assistants, and some of them will actually use computer programs. The problem is when you translate something, a lot of times you don't just need to translate the word verbatim, but you have to actually look at what the meaning is. So the translator I hired for that book, he would actually translate it, modify it based on what he thought I wanted to do using the English version. And then we would get together, read it together, and try to figure out if the point was where we wanted it. And so it was actually a longer process than most people realize. Like I said, I will never translate something from Spanish to English or English to Spanish because it's a headache. In academia, when we're actually dealing with stuff, we are going to be using the most recent data. So a lot of times things change. We're going to also be using any new technology we can to help ourselves. Reason is, new technology will make our lives easier. So we actually will do data. We're constantly dealing with the facts as we find them. And one of the things we find is the bigger the numbers, the better. Now, sometimes in academia, we do something different. As well as that, what we will do is we'll take a semi-unrelated topic and look into it. I actually remember a friend of mine had a friend who was studying, she was getting a master's, I think, in anatomy and literature, human anatomy and literature. And what she did is she actually went to old texts, old historic anatomy texts to try to find out how things were versus how they are in literature. So she went from literature to anatomy to try to put the perfect picture together. Sometimes, for instance, if you're actually interested in martial arts and martial art research, you'll find that there's very little actually written in martial arts. So a lot of times we have to go to other areas to find this. So for instance, you may actually look at a specific move in football, see a certain injury, for instance, the unhappy knee triad that happens from clipping. And you can then end up seeing how the injury happens and use that in martial arts. We can actually take different things and get a better understanding by comparing different things, looking at how things move, looking at why people move a certain way. And with that, we can end up getting a stronger and better view of the world. I will tell you, not too long ago, I actually decided to see if I could model how the COVID-19 was going in the US. And what I found is a lot of points, and I used 1 million as one of the big points because big number, round, you can see it. So I saw how long it took us to get to 1 million, which was about 3 months, how long to get from 1 million to 2 million, which was 2 months. And I actually did a graph and I calculated that in 1 month, we would end up having one more month from 2 million, we'd have 3 million. And it actually came out perfect. So I was, wow, this actually works. We probably will reach 4 million by the 29th of this month. And I ended up finding out today that, well, we were 7 days early. So I was a week early on that, which means that I have to go evaluate my numbers to see if I can make it better, to see when the next million mark would be hit. Right now, I would calculate probably in about 2 or 3 weeks. But without doing the math, I'm just talking. So, what is fascia, first of all? Well, fascia is connective tissue, and there are some reports that say that they can find some contraction into it. But most of those reports say that that contraction is negligible at best. So it's connective tissue, and I'm actually going to talk about that a little bit more. But before that, I want to actually go and talk about what is contractile tissue. This is tissues that actually cause contractions when they're stimulated. And we can actually talk about three different types of contractile tissues. One of them is striated skeletal muscle, one of them is striated cardiac muscle found in the heart, one of them is found in your, pretty much the one you use to move, which is the one I've been talking about more recently. And the last one is smooth muscle, which is found mostly in your bronchioles and digestive tract. All of these have something very similar. They actually are made up of a lot of cells. In the case of striated skeletal, they're actually fused together to give you even more of the intercellular proteins. But smooth muscle would be the one that would be most compatible to fascia. And even there, you have a lot more cells than other stuff, which we'll call matrix. What we find is in all three contractile tissues, the contractile elements are inside the cells. So what it means is that to have a contraction, it usually means you have cells. I don't know a case where you don't have cells for contraction. I'm sure there's one out there, but we need cells to cause contractions. Now, the contractions are what cause movement. Yes, we can actually cause a little pulling of tendons, which are dense regular connective tissue, and use the relaxation to cause a little bit of a bump, but usually that bump is caused by the antagonistic muscle going against it. There are a lot of things that people have actually found, electromyograms. I'm not going to go into that right now, but we're talking about fascia. Fascia is pretty much the membranes that wrap around muscles. Sometimes they actually refer to certain tendons that wrap around another muscle as a fascia. So for instance, you have something called the muscle called the tensor fasciae latae, and the iliotibial band, which is a tendon, is the fascia that they're talking about. Now, when we're talking about that, and I'm actually going to use this Martini book, you can actually see here what's called areolar tissue or loose irregular, and you'll notice that there's these purple dots. I don't know if you can see them too well. I'll bring it closer. You see some of the purple dots. Those are the cells. If you look at the two that make tendons, ligaments, you're talking about the dense regular and dense irregular connective tissue. And again, you can see some cells, the purple dots, but not very many. As you need the cells to contract, tendons and ligaments, while they may have some contractile because of the cells, have minimal or even neglectable contractile properties. That means that anytime someone's telling you, oh, you contract the fascia to do something, they don't understand what it means. Now, there are other people who actually will talk about fascia as a communication tool. And I'll go into this. There are actually a couple different ways cells can communicate. You have what they call autocrine, where a cell sends a message to itself. This would be kind of like you setting an alarm for yourself to wake up a certain time. Paracrine is a cell sends a message to the cell next to it. Usually you have one cell that's actually monitoring and the other cell that actually causes the action. And so the monitor cell sends a message to the cell next to it, which causes an action. There's actually also another thing called neurocrine, which is neurons send messages to other cells, which cause reaction. And then we have endocrine. And endocrine is when a cell sends a message directly into the blood system, which goes around the body. Now, at present, these are the only ways. You can actually talk about exocrine too. Usually that's not something we talk about in humans unless you're talking about sweat. But usually these are the ways that we talk about cell-to-cell communication. This is what causes messages to be sent. You do have some cells that can actually work with ions. Usually those are the glial cells. Talk to them when we get to neural. But one of the things that happens is you need some way to send messages back and forth. Now, the fascia really doesn't have a good blood supply. So you cannot use endocrine to send messages to fascia. That would be really slow too. Neural, well, you do have some nerves going through there. Usually they're actually found in the tendons, which are stretch receptors telling the muscle that it's stretched, so to contract. Not really the fascia, it's really the neurons within the fascia going to another tissue. So that's not really the case. Paracrine, the cells in fascia, if you look at the cells in connective tissue, they're relatively spread out, and so you're not going to have really good cell-to-cell communication. And so the big thing that happens is you really don't have much communication within fascia. There's also not as many ions as people would like to believe. It tends to be your basic tendon, if you actually are looking at it like that. So, how important is fascia for martial arts? First, I would say very, because it is actually one of the tissues that helps structure muscles. If you're actually dealing with tendons as fascia too, which I saw some people do, technically most people separate tendons from fascia, but there are some cases where it is. Again, you're dealing with the muscles, the important thing, not necessarily the fascia. And so that's actually one of the big things is, yes, there are a lot of things out there. There's a lot of people who want to believe certain things, but only through taking what we already know through textbooks, for instance, seeing if what the research matches a textbook, and then seeing if the specialist in that area is saying the same thing. So for instance, if someone who is a PhD in histology, studies tissue, is telling you, well, this is the tissues and how they work, it carries a lot more weight than someone who, even as maybe a medical doctor, tells you, well, this is the way the tissues work. If there's one thing that's different, you always go with the guy who's the expert. So again, fascia is important, but it's not used for communication or contraction. So a lot of time when you actually start reading this, pay attention, go back to your anatomy book if you haven't, go back to PubMed and see if it makes sense. I hope you enjoy this, and I will continue more with power in the legs next time. Have a nice day.